Next we have our question number 23, which is in the form of a cube plus b cube and a cube minus b cube. And we know some conditions that a cube plus b cube can be written as a plus b of a square plus b square minus ab, and similarly a cube minus b cube can be written as a minus b of a square plus b square plus ab. These are the two standard values we'll be having for a cube plus b cube and a cube minus b cube. Let's expand our numerators in this form. This cos cube plus sin cube can be written as cos a plus sin a of cos square a plus sin square a minus cos a into sin a. And the denominator remains same, which is cos a plus sin a. And our next term, which is a cube minus b cube, which can be written as cos a minus sin a into cos square a plus sin square a plus cos a into sin a. And the denominator remains same, which is cos a minus sin a. And if we observe here, cos a plus sin a, and here both the negative terms get cancelled. And here we are remaining with cos square plus sin square, and we know our identity that cos square or sin square plus cos square can be written as a. So I'll replace this cos square plus sin square with 1. So here we'll be having 1 minus cos a into sin a, and the second term cos square plus sin square, this again we'll write it as 1 and plus cos a into sin a. And here we have minus and positive terms. So remaining values are 1 plus 1, which is equals to 2. This is our required RHS value. Next we have our question number 24, which are in terms of tan and cot, and we need to get our answer in the form of secant and cosecant. Let's convert this tan and cot in terms of sine and cos. This tan can be written as sine a by cos a, and the denominator cot can be written as cos a by sine a. This is our first term. Next we have cot a, which is nothing but cos a by sin a, and the denominator will be 1 minus sin a by cos a. First let's take the LCM of these denominators. This numerator remains same, cos a by sin a remains same, and then denominator will get sin a minus cos a by sin a. And our next term is cos a by sin a, and the denominator will be cos a minus sin a by cos again. Let's transpose the denominators to the numerator. So thus values will get it as reciprocal. That means we'll get it as sin a by cos a into sin by sin a minus cos a. This is our first term. Next we have cos a by sin a into cos a by cos minus sin. If we observe here, sin minus cos, cos minus sin, that is a minus b and b minus c, we can take this term as common. Let's take it out. 1 minus sin a minus cos a, let's take it out as a common. And here sin into sin is sin square a, and the denominator is cos a. Here we'll get it as minus because we have taken out sin a minus cos a as common. Whereas here we have cos a minus sin a. So here we'll be getting it as minus. And cos into cos is cos square a by sin a. Again here we have to take the LCM of the second term. So we'll get it as 1 by the sin a minus cos a remains same. Let's take the LCM here. We'll get it as sin cube a minus cos cube a by cos a into sin a. Again here we have a cube minus b cube form. What is our a cube minus b cube? So a cube minus b cube is nothing but a minus b into a square plus b square plus ab. Right? This is our a cube minus b cube form. Let's expand this. Here we'll get it as sin a minus cos a into sin square a plus cos square a plus sin a into cos a. and the denominator will be product of these two terms, that is sin A minus cos A into cos A and the product of sin A. And we have our identity, which is sin square plus cos square is equals to 1. Let's replace that value with 1. We'll get 1 plus sin A by cos A, and the denominator is cos A into sin A. It remains same. In numerator we have two terms. Let's divide that into two different terms. We'll get it as 1 by cos A into sin A plus again the second term, which is sin A into cos A by sin into cos. And we know inverse or the reciprocal of cos is secant and inverse of sin is cosecant. And here all the values gets cancelled. We'll get it as 1. This is our required RHS value. Next we have a question number 25. We need to get our answer in terms of sine and cos. So let's convert this cot and tan in terms of sine and cos. So in this we know cot can be written as cos by sine. Right? And second term, which is cos, remains same, and convert this tan in the form of sine by cos. And let's take the LCM of these two denominators separately. We'll get it as sin A by sin A plus cos A. And the second term, which is here the denominator remains same, which is sin A, and here the second term will be cos A plus sin A by cos A. Now let's transpose this denominators to its numerators. We'll get it as sin square A by sin A plus cos A and minus cos square A by cos A plus sin A. And if we observe here, we are having same denominator. So let's combine both the terms. We'll get it as sin square A minus cos square A by sin A plus cos A. So the numerator is in the form of A square minus B square. A square minus B square is nothing but A plus B into A minus B. Let's expand this in that form. We'll get it as sin A plus cos A into sin A minus cos A. And the denominator is same, which is sin A plus cos A. Here we can cancel these two terms. So our remaining answer will be sin A minus cos A. This is our required RHS value. Next we have our question number 26. Here we need to get our answer in terms of secant. So in terms of secant means we need to have in cos, and this tan can be written as sin by cos. Let's write this tan as sin theta by cos theta plus this sin remains same, and again here this tan can be written as sin theta by cos theta minus sin theta. Let's take out sin and sin from the numerator and denominator as the common term. We'll get it as sin theta of 1 by cos plus 1, and the denominator will get it as sin theta of 1 by cos minus 1. Here sin and sin gets cancelled, and the remaining values are 1 by cos plus 1 by 1 by cos minus 1. And here we have inverse of cos. Inverse of cos is secant. Secant theta minus 1, secant theta plus 1 by secant theta minus 1. This is our required RHS value, question number 26. Next we have our question number 27, which is in terms of cot and cosecant, and we need to get our RHS in terms of cos and sin. Here we have our identity, which is cosecant square theta minus cot square theta is equals to 1. Let's replace our numerator 1 with cosecant square minus cot square. Leave all the remaining values as it is. We'll get it as minus of cosecant square theta minus cot square theta. Leave the denominator as it is as of now, cot theta minus cosecant theta plus 1. And multiply this negative sign to the terms which are inside the bracket. We'll get it as cot theta plus cosecant theta plus cot square theta minus cosecant square theta. And if we observe this, it is in the form of A square minus b square, which is one, what is that? Cot square theta minus cosine square theta. It is in the form of a square minus b square. Let's expand that in that form. A square minus b square is a plus b into a minus b, right? So we'll get it as cot theta minus cosine theta and cot theta plus cosine theta, and the whole denominator is cot theta minus cosine theta plus 1. And we know that this is one term and this two are in product, so this will come as a one term. And here we have cot theta plus cosine and cot theta plus cosine as common. Let's take it out as a common term. We'll get it as cot theta plus cosine theta. So here we'll be getting 1 plus cot theta minus cosine theta as a second factor, and the denominator remains same. If we observe here, the numerator term and the denominator term both are same. Let's cancel out. Here we'll be getting it as cot theta plus cosine theta will be our remaining answer. Now we have to convert this in terms of sine and cos. And cot can be written as cos theta by sine theta, and cosine can be written as 1 by sine theta. So here we are having same denominators. Let's combine both the numerators. So we'll get cos theta plus 1 by sine theta.